Hello everyone! Today we are going to look at Rowstore indexes. Now this is going to be a very brief overview because to properly cover index theory this would be a very long video and you would get sick of listening to me talk. If you want to understand more about B-trees and leaf nodes etc, then maybe I'll do a theory video at a later date, or feel free to have a Google, because today we're just going to look at creating them with a very simple explanation of what they are. So you may or may not be aware that we now have two formats of indexes in SQL Server, which are column store indexes, which group data by the column. These are great for aggregated data sets like data warehouses, etc. Or we have row store indexes, which are good for identifying a single row within a data set. So we're going to cover the latter today and just talk about the difference between clustered and non-clustered indexes, and we have an example here of how to create a non-clustered index. So if we don't put an index on a table, then SQL has to scan the entire table for the row that you're asking for every time, which, as I'm sure you can understand, is pretty resource intensive. So we can have a look at what indexes we have in a table over here in our Object Explorer. If we just click the plus sign on the table, go down to indexes, and we can see here the indexes that we have per table. So an index is used to locate a specific row of data on the disk. So this works very much like the index in a book, which points you to the page the information you're looking for is on. So each table can have one clustered index and multiple non-clustered indexes. The clustered index is usually your primary key, and so when you create a primary key constraint, this also creates a clustered index on that column for you, which you can see here. A clustered index is very quick to read from because it governs the way the data is physically stored on the disk. So that's why you can only have one clustered index, because the data can only be stored in one way, obviously. It's best to have your clustered index on something which will be incrementing, because if you put it on something like surname here, where records are going to be inserted here, there and everywhere, then SQL will have to reorder the data on the disk every time you do an insert, which is obviously very expensive resource-wise. So as I said before, a clustered index is created when you create your primary key. So I'll not cover creating these because I hope all of your tables have primary keys already. And looking at non-clustered indexes, these are slightly different from clustered because it stores a pointer to the location of the data for the columns that you specify. So you can have many non-clustered indexes per table, but don't be tempted to put one on everything because this also has performance overheads. So to create one of these, you're just going to type here create non-clustered index, and then the name of your index and the table that you want to put the index on, and then the column. So if I just run this here, and we can just refresh this here, and we can see the new index that we've created here. Now we can also put these on multiple columns if we wanted to. So if I wanted to put one, for example, on I don't know, first name and surname, which I'm not going to run this because we've just put one on surname, but we would just type this like that there. So you could just put in the a comma there between the multiple column names that you want. So that's pretty much it, kind of simple, right? When you don't cover all of the theory. The next tutorial I'm going to cover the include statement, and we'll look at why you might want to include additional columns into your index there. So if you enjoyed this tutorial, please like and subscribe to our channel. Feel free to add any comments below.